In this lesson, we're going to look at graphing quadratics using transformations. So a transformation is when we take a function and we move it, and we slide it, or we flip it around, all right? We've already seen that if we have the graph of y equals ax squared, that's going to take the graph of y equals x squared. That would be the parent function y equals x squared. And that's just going to kind of either flip it or stretch it. That can be done by multiplying by a number in front of the x squared. Well, now we want to see what happens if we add or subtract in some numbers inside or before we square or after we square. So first, let's investigate what happens when we add or subtract before we square those. All right. So we're going to look at some of these functions here, and we'll go to our graph here to check it out. So here's our y equals x squared. Now the question is, what happens when we have y equals x plus 3? And we close the parentheses and square that, all right? So the blue parabola is x plus 3 squared. That's kind of interesting. And what happens here if we change that to a plus 4 or a plus 5 or a plus 6? Okay, see what's happening? It's moving to the left. Okay, plus 9, we'll move it all the way to the left. It doesn't change shape, but it's moving the other way. What if we go minus? Minus 1, minus 2, minus 3, so on and so forth. Well, if we subtract inside, the shape's not changing, but it's moving right. What if we had like a 2x squared? Well, if we have 2 times x minus 6 squared, again, it's going to move to the right. So this is moved right 6. Now it's opposite. Watch out for that. So that sign is opposite. So if we look at these graphs here, if we started with y equals x and we have x minus 3 squared, well, the graph's going to be over here. If it's x plus 3, well, we're going to come over to here, and it'll be our parabola over there. If we have 2 times x minus 4 squared, well, x minus 4 is going to put us over here on the right, and that 2 is just going to make it a little steeper. X plus 4 is going to take us over to the left, because adding goes left. It's opposite. Now the negative, here we have a negative 1/2 x. It's going to look like this negative, which means it's going to go upside down. It's going to be a little wider. So that's the general idea there. So to summarize this, oh, we got one more hiding over there. Let's see what that is. So what if we have x minus 5? That's to the right, 5. And since there's a negative 3 in front, it's going to be steeper than y equals x squared, okay? So the idea is this. If we have the graph y equals a times x plus h squared, okay? So how does that h change the shape? Well, if h is greater than 0, in other words, if we're looking at something like y equals x plus 3, well, that's going to move left if it's plus in the inside. If we have y equals x minus 3, in other words, the number inside is less than there, okay, then that's going to move right. So let's see how this works in practice here. So we've got an equation we want to graph. We want to graph y equals x plus 3. And so we're going to relate this to y equals x, all right? So now we notice the plus 3. Plus 3 is going to move it right. No, I'm sorry. It seems like it's going to move it right. I got to be careful there. This moves left. Remember, left and right is opposite. 3. So it's the same shape, and it moves left. So what we're going to do here is this. We're going to think about y equals x, the graph of y equals x squared. So y equals x squared. The points are 0, 0, 1, 1, 2, 4, and that's good enough. Negative 1, 1, negative 2, 4. If you want to go to 3, 9, you can. 4, 5, 6, 7, 8, 9. All right. So there's our points. Now we're going to move everything left. So what you can do is you can look at these points here and realize that everything's going to move left 3. So take the vertex and move left 3. Okay, so if the vertex moves left 3, there it is, there's going to be x plus 3 squared. So you can either look at each point and just move them left 3. Left 3 is going to put us right here, so on and so forth. Or just start from the vertex and say, well, from the vertex, it's going to act like these blue ones. Right 1 up 1, right 2 up 4, right 3 up 9. Okay, that's the pattern for a parabola. All right, it follows the y equals x squared, always starting from the vertex. Left 1 up 1, with 1 squared is 1. Left 2 up 4, because 2 squared is 4. And we get that kind of thing there. So there it is. So you can plot the blue ones, that's optional, and then move everything left 3. Okay, or just start with the vertex and work from there. Now we'll throw one more piece into the here. All right, so we know that if we multiply by some number out here, that changes the shape or flips it upside down. If we add or subtract inside, that moves it left or right. What happens if we add or subtract outside? Well, that's what we're going to figure out here. Okay, what happens if we add after we're squaring? Well, if we consider this, if we have the function f of x, that represents the height. The f of x is the y value, which represents the height of the point. All right, so we can think about it there. If we take f of x and we add to it, well, that's going to add to the height. So if we take f of x equals x squared and we add 2 to it, and get a new function called g of x, well, that's going to move the whole thing up. All right, let's just kind of investigate that here. So we're going to have y equals x squared. And so now if we throw a plus 1 after that, it goes up. Let's actually do this. I'll start a new one. There's y equals x squared. So y equals x squared plus 1. Okay, so if we add 1, that's up. Add 2, add 3, add 4. Okay, and we can see that we get this nice movement there, all right? In fact, if we add, I'll make a slider here, all right? So if we add a positive number, it's moving up. If we add a negative number, it's moving down. So that number outside gives the up and down movement, okay? If we add a positive constant to k to the outside here, that's going to move it up. If we add a negative constant k, so positive is up, negative, in other words, we subtract, that's going to move it down. All right, so outside is up or down. All right, and this affects whether it's the maximum or the minimum value, all right, because it moves that vertex and everything else up. All right, so if we wanted to find the maximum or minimum of these quadratic functions, we can find the vertex there. Okay, find that, is it going up or down? Well, let's look at this one. This graph is opening up, and the plus 5 is going to make it move up 5. All right, so it's moved up to 5 here. So this is a minimum value. We say that this function has a lowest point, or a minimum, of 5. So that's the lowest point, or the minimum is 5, we could say. All right. This guy here, well, what's happened? The negative 3 flips it upside down, and it makes it a little skinnier because negative 3, or steeper. And the minus 4 moves it down. So it's flipped, and it's moved down. And it's a little skinnier, but we just want to know if it has a max or minimum. Well, it's moved down 4. Instead of being at 0, 0, it's down to negative 4. So this is as a minimum. I'm sorry, that's a maximum. It's a highest point of negative 4. So negative 4 is the highest that will go. All right, and last but not least, This has moved up 7. There's other stuff that has happened. It's opening up. And so this is going up 7. And this is going right 5. And it's opening up. So we're going to go right 7 and up 5, somewhere right up here. And it's opening up, and it's a little steeper, but that doesn't matter. Come on. Okay, anyways, so this is a minimum value. So the lowest value, the minimum is the lowest y value. And so here the minimum is 7. That's the lowest it will ever reach there. All right. So we now have this, what we call vertex form, which is a very useful form. All right. And so it tells us if it's moved vertically or horizontally, if it flipped, is it the rate of change or the stretch changed. That's all summarized in this form, a times x minus h squared plus k. Okay, so the key here is that the a coordinate affects the vertical stretch. And if it's negative, it'll flip it upside down, all right? So it also determines whether it opens up. If a is greater than 0, then it has a minimum value. If it opens down, then it has a maximum. Okay. This h number here is going to move it horizontally, and this one is opposite. So remember, minus 3 is going to move it right, and plus 3 is going to move it left. And that does affect the axis of symmetry. We can call that x equals h there. Then we have this k value, and that shifts it vertically, k units. And that'll tell us where the maximum is at. That maximum or minimum value is equal to k. That's where it's at. And then if we put all that together, we get the vertex. H and k together give us the vertex, because h tells us how far left and right it's moved. K is how far up or down. And normally our vertex is at 0, 0. So let's put this all together to write some functions. We know that y equals a times x minus h squared plus k. That's our vertex form. The vertex comes from the h and the k. This moves it left and right. This moves it up and down. And this moves the stretch and flips it. So if we know we have a parabola here that is twice as steep as y equals x, well, that means we have y equals 2 times, because it's twice as steep. It's moved left 5. Well, that's x. Left, remember, is opposite from what we expect. Left and right are opposite. It's moved down 14, so we're going to go down 14. That's minus 14. So now we can write a function here, okay? The vertex would be at negative 5, 14. That's useful to note. They didn't ask for that, but negative 5, negative 14. All right, what if we flip that around and we're given the function? Where is this graph, and how does it compare to y equals x squared? Well, the negative in front, that's going to flip it or reflect across the x-axis. Okay, reflect across the x. And then what about that 18? What's going on there? Well, the 18 is inside, so it's left and right. So it's opposite. Minus is going to move it right 18. Okay. Then the 9 is going to move it up 9. Okay. Right 18, up 9. So the vertex is going to be at 18, 9. Because it's moved right 18 and it's up 9. So this is our HK, that's our vertex there. All right, so let's use that to get some graphs here. So if we want to graph this, what we need to do is, 1, find the vertex. And the vertex is HK. HK. Now remember, in our standard or vertex form, y equals a times the x minus h squared plus k. So what number's in the h spot? 2 is. And what number's in the k spot? Negative 4. So this is 2, negative 4. So 2, -4 is where we're going to have our vertex. We'll mark that here. This is going, we'll go by ones. Okay, so this is 10 out here, and this is 10. Okay, so the axis of symmetry goes through that. That's x equals 2. Notice the a value is 1/2, so it's going to open up. Okay, it's going to open up, but it's going to be half as steep. Normally, we'd go right 1, up 1, because 1 squared is 1. So from the vertex, we go right 1 and up 1. But we're going to go right 1, up 1/2. Okay? Normally, 2 squared is 4. We go right 2 and go up 4. That's what you do for y equals x squared. But we're graphing y equals 1/2 x. So we're going to go up half the distance. We're thinking y equals 1/2 x squared. From the vertex, for y equals x squared, we go left 1, up 1, but we're only going to go up 1/2. We're just reflecting this point across here. Reflect this point across the axis of symmetry. Here's our axis of symmetry. It's going to end up over there. And that's good enough. 5 points is usually pretty good. Avoid big globs like I end up here because I zoomed in. But that's the idea. Okay, so does it have a max or min? Well, it has a min. Its lowest point is a minimum, and its minimum is -4. The domain, the x values that are allowed to be put in there is all x values. The range goes from -4. There is a point down at -4, and then the y values go up forever. So the y values go up to infinity. Okay. Well, how about one more here? So we've got a vertex. We've got -2 times x plus 1 plus 2. So the vertex is here, hk. Now remember, our vertex form is a times x minus h squared plus k. So we have to ask ourselves, what number is in the h spot? Well, it has to be a -1 because minus 1 makes it plus. So the vertex is -1, and then we've gone up 2, so it's at -1, 2. The axis of symmetry is x equals -1, horizontal line that goes through the vertex. Okay, now this is opening down, so it's going to be down, and it's going to have a maximum. It's going to have a max at x equals 2, because that y value is the maximum. All right, so let's draw it, and then we can answer the domain and range. So the vertex is at -1, 2. So let's mark that. -1, 2, there's our vertex right there. Then let's look at our numbers again. Okay, our shape is -2, our shape number, that a value. So that means we've flipped it upside down, and it's going to look like y equals 2x. So it's going to be flipped up, down, and we're thinking y equals 2x squared. So that's doubling the x squared. So normally we'd go right 1 and, in this case, down 1 if it was 1x squared. But now we're going to go down twice as far, 2. Normally we'd go left 1 and down because it's negative, down 2. Okay, but we're going to normally go down 1, but we're going to go down 2. Okay, normally we would go right 2. 2 squared is 4. But we're going to double. Okay, instead of going 4, we're going to go twice as far. We're going to go 1, 2, 3 off the screen, 4. Okay, so 4 is right down here. Now, normally from the vertex, we go left 2. 2 squared is 4. But we're going to double that to go to 8. Okay. So there's 5 points. That's pretty good. You can see that it's steeper because of that 2x squared. Okay. There's the idea. Oh, and our domain and range. Well, the domain is all real numbers. You can square anything you want. Okay, -infinity to infinity. The range, well, The range is going to go on up, the y values. There's y values all down here, and they stop at 1. Okay? So we have all the low negative numbers, and we're going to stop at 1. Okay? All right, that's how you use vertex form to graph it, all right? The next challenge we'll have is to change things into vertex form, because this is real nice. This is nice here because if it already is in vertex form, we can just plug in the vertex and use that shape number out in front to get the rest of the graph.